when I run the bash command, as I've just done with docker run, make a new container with a certain custom name based on my SE welcome image, and I added in the command I wanted to run when the container launched. Instead of the default, I'm launching the command line interpreter of the container. What you'll see is I'm actually now logged in to the container and I'm looking at the command line of the container. I'm logged in as root in this container, which is the ID of the container. And I'm in the welcome directory, which, if you remember, is the working directory that I configured the image to have. So that's the directory I'm by default put into. I can do pwd to show what directory I'm in. And I can cd / take a look. This actually is a classic directory structure of a Linux computer. And so I'm in a virtual computing environment, a container environment, which seems to be running Linux. Of course, the container doesn't include necessarily the entire operating system, but it nevertheless appears to be a fully functioning Linux computer. And I can just use this computer as if it was my own regular computer. I'm of course in a virtual environment, a virtual computing environment called a container, which is a guest computing environment on my physical host machine, which is running Mac OS. But nevertheless, I seem to be in a Unix Linux environment here. And I can do all the things that Unix and Linux can do. If I want to exit this and go back to my host command line, I can do exit, and then I'm popped out. Docker ps-a, and I'm now exited from that container. It's still there, but it's exited, and I can again docker rm and paste that in. If I'm curious what images I have on my machine, I can do docker images. That will show me all the images I have currently downloaded from Docker Hub or from somewhere else. You'll see the one I've just been using is there. It's got a certain ID, the image ID associated with it. And if I want to remove that, I can do docker rmi, paste that, and that will now be wiped out of my machine's memory and hard drive. So you can prune or remove images, you can prune or remove containers. So they, by default, will stay around, but you can go in and remove them if you need to. All right, let's go back to the slides here. I've got shortcuts for many of the common commands that you would want to run from Docker, and I have some explanation of some of the options you can give. So I'll skip that because we've already talked about that to some degree. But I do want to get to the next bit here about networking. And this is important because very often you want your containers not to run in isolation, but to be connected to other environments or other computers. By default, your containers will be closed off to the outside world. As we've seen, giving the -ti flags when you instantiate a container will allow keyboard input to be forwarded into the container and system output to be forwarded out of the container to the host machine. So that's one way we can tie the container to the outside world a little bit, have text input or output forwarded in or out of the container. Another way is through ports. So you can do port mappings where we can say a certain port of the host machine will be mapped to a certain port of this container machine. So the container has its own ports, just like the host machine has its own ports. Let's say you're running a web app, a Flask app perhaps, on port 3000 of the container. So if the container is actually running a Flask application on port 3000 of the container, you can say your host machine's port 3000 or whatever number you choose will be forwarded to the container's port 3000. So you can configure host machine ports to map to container machine ports. And then if you wanted to, you could do something like localhost :3000. I don't know if you can see that on my machine, but I'm going to localhost at port 3000 in a web browser. And if I had mapped this, it would forward my request to my local host on port 3000 to actually the container's port 3000. And if the container was running a Flask app that was listening on port 3000, its response would be visible in the web browser. I'm not running a Flask app, so it's not doing anything. That's the idea of port forwarding. And then we have the ability to do multiple ports, so you're not just stuck with forwarding one port. You can forward a certain port on the host machine to a port on the container, and another port on the host machine to a different port on the container. Whatever you need to do in terms of making ports in your container accessible from the host machine. That's it for now. When I get the chance, we will talk about networking multiple containers to each other. So rather than just forwarding requests on the host machine to the container machine, we can actually have container-to-container conversations by creating a sort of a local network within which multiple containers can run. So we'll discuss that as a separate matter, and I'll stop this for now.